Welcome to Pratham Science Academy classes, and we are going to start the second series of EFIGH of board question paper of 2023. And let's quickly move on to the section A. So section A has MCQs from 1 to 18 and 19 to 20 are region and region-based questions of 1 marks each. So our first question is, it's given that matrix A is given and we have to evaluate it for A raised power 2023. So it's A which is 0100. Now A raised power 2023, I can write it as A in A square into its 1011. So this will give us this is 2022 and we are left with one matrix, so I can add it here. And so this is, I can write A raised power 2023 as A square raised power 1011 into A. Because A square raised power 1011 will give us A022 and into A will give us A raised power 2023. Okay. Now let's calculate what is the value of A square. So A square will be the multiple of 0100, which gives us 0 into 0 plus 1 into 0. First row, first column, and then first row, second column, second row, first column, 0 into 1 plus 0 into 0, which gives us 0, 0, 0, 0. So this is a zero matrix. So if this is a zero matrix, raised to power 1011 will be 0, and eventually this will give me zero matrix. So our answer is 0, 0, 0, 0, and which is option C. Let's move on to question number 2. For question number 2, it's given that if 2054 is equal to P plus Q, where P is a symmetric and Q is Q symmetric matrix, and what is Q equal to? Okay, so we are given that it's 2054 matrix is equal to P plus Q, where P is symmetric and Q is skew symmetric. Now we know that every matrix can be written as a sum of symmetric and skew symmetric matrix. So this is half into A plus A transpose minus plus half into A minus A transpose. So this portion is symmetric and this one is skew symmetric. Now if we compare these two portions, so this Q is equal to half into A minus A transpose, and A is 2054. So let's put in the value and calculate it. So this is half and A is 2054 minus. This is has to be transpose of A. So this has to be transpose of A. So Q is equal to half. This is 2054 minus. Now the transpose is 2054. Convert the rows into columns. All right, so we have Q is equal to half of 2 minus 2 is 0, 0 minus 5 is minus 5, 5 minus 0 is 5, 4 minus 4 is 0. So which gives us 0 minus 5 by 2, 5 by 2 and 0. So Q is equal to 0 minus 5 by 2 and our option is C. Moving on to question number 3. Okay, for question number 3, it's given that if 1 to 1 is a non-singular matrix. A non-singular matrix is a matrix whose determinant is not equal to 0. So given matrix is 1, 2, 1, 2, 3, 1, and it's free A1, where A is an element that belongs to, let's say, matrix A. Then what would be the value of set A? So A belongs to some set A, then what would be the value of set A? So it's given that it's a non-singular matrix, so that its determinant is not equal to 0. Let's find out its determinant. So to find out the determinant, 1, 2, 2, 3, 1, let's expand it along row R1. So this is 1 into determinant of 3, 1, A1 minus 2 into determinant of 2, 1, 3, 1 plus 1 into determinant of 2, 3, 3. Okay, now this gives us, this is 3 minus A minus 2 into, this is 3, so this is 2 minus 3 plus 1 into 2A minus 9, which gives us 3 minus A. 2 minus 3 is minus 1, and into minus 2 is plus 2 plus 2A minus 9. Okay, minus A plus 2A is A, 3 plus 2 is 5, and 5 minus 9 is negative 4. Okay, so this is the determinant of the matrix, and it's a non-singular. So this is non-singular matrix, so that means its determinant, it should not be equal to 0. And it should not be equal to 0 means that we can have all real numbers here except 4, because if we have 4 here, that will make it 0, and then it will not be a non-singular matrix. So A belongs to all real numbers except set x4. So our option is option D, all real numbers except 4. And let's move on to question number 4. Okay, for question number 4, it's given that determinant of A is equal to determinant of K into A, where A is a square matrix of order 2. Then what is the sum of all passive possible values of K? So we have to find the sum of all values of K first. Okay, now for this we have the property that says determinant of K into A is equal to K raised power n into determinant of A, where n is the order of the matrix. So in this case, the order is 2. So n is 2 here, and I'm going to replace this value. So this is that A is equal to K square into determinant of A. This gets cancelled, and K square is equal to what? So K is equal to plus minus 1, and sum of plus and minus 1 is equal to 0. So D is the correct option here. And let's move on to question number 5. For question number 5, it's given that the differentiation of some function is equal to ax plus b. And also it's given that the value of the function at 0 is equal to 0. We have to find the f of x. So let's integrate, reverse the process, integrate on both sides. So this is integration of the differentiation of the function and integration of ax plus b. So integration of the differentiation of the function will give us the entire derivative f of x. Integration of ax is ax squared by 2. Integration of bx is bx, and don't forget to add the integral constant. Okay, now it's given that the value of the function is at 0 is 0. So if I put the value, try to calculate the value of the function, so this is a into 0 squared by 2 plus b into 0 plus c. So this is 0, this is 0. And when the function at 0 is 0, so c is equal to 0. And now this function, let's put in, replace the value of 0. So this is function is ax squared by 2 plus bx plus c is 0. So this is our answer, and it should be the option B. Okay, for Question number 6, we have to find the degree of the differential equation and the degree of the differential equation. Let's write it down. So this is cos of dy by dx. Okay, we do have the order for this differential equation, but the degree is not defined because in any case, we are not going to get this. So we do have the order is 1, but this cos of dy by dx is not possible. So the degree is not defined in this case. It's not defined. And let's move on to the next page. Okay, for question number 7, we have to find the integrating factor of the differential equation. And the differential equation is 1 minus y square into dx by dy plus yx is equal to ay. Okay, first of all, let's try to get it into the form dx by dy plus bx is equal to q. So this can be written as dx by dy plus y upon x upon 1 minus y square is equal to ay upon 1 minus y square. Okay, and if we compare this with the form dx upon dy plus px is equal to q. So here p is equal to, if we compare these equations 1 and 2, so p is equal to y upon 1 minus y square, and we have to find the integrating factor. So the integrating factor is integration of, this is p into dx, sorry, p into dy. So integrating factor is p into dy. So this is integration of p is y upon 1 minus y square into dy. So let's integrate this. So integration of y upon 1 minus y square into dy can be, let's assume that 1 minus, okay, or let me just multiply this with -2. So multiply and divide it with -2. So -1 by 2. Have taken the negative in, so divide it by 2 and multiply it with 2. Or if you want, you can also evaluate this using the substitution method. So let's say 1 minus y square is equal to t. So differentiation of this is minus 2y into dy is equal to dt. So dy into dy is equal to negative dt by 2. So this becomes, this is negative dt, half is out, and this is t. So this is minus half log t, and let's put in the value of t. This is negative log 1 minus y square, and I can write it as log of 1 minus y square raised power negative half. Okay, so this is now integrating factor is integration, or integration is log of 1 minus y square raised power minus half, and we know that e raised power log x is equal to x. So this is equal to, this is now equal to 1 minus y square raised power negative half, which I can write as 1 upon 1 minus y square raised power half, and which is equal to 1 upon under root of 1 minus y square. So 1 upon under root of 1 minus y square, option D is the correct answer. And let's move on to question number 8. Okay, so for question number 8, we have to find the unit vector along PQ where coordinates of P and Q are. So coordinates of P are 2, 1, and -1. And the coordinates of Q are 4, 4, minus 7. And we have to find the unit vector along PQ. So let's first of all find PQ vector. So PQ vector is the position vector of Q minus position vector of P. Position vector of Q is 4i cap plus 4j cap minus 7k cap. Position vector of P is 2i cap plus j cap minus k cap. So this gives me 4 minus 2 is 2i cap. 4 minus 1 is 3j cap, and minus 7 plus k is minus 6k cap. So this is our PQ vector, and we have to find the unit vector. So let's find out its magnitude as well. So magnitude of PQ is equal to under root, it's 2 square plus 3 square, 2 square plus 3 square plus negative 6 square. 2 square is 4, 9, 3 square is 9, 6 square is 36. So this is equal to under root 49, which is equal to 7. Now the unit vector we all know is given by the vector divided by its magnitude. So it's 2 by 7 I cap plus 3 by 7 j cap minus 6 by 7 k cap. So this is our unit vector, and it matches with the option D, 2i cap by 7 plus 3 by 7 j cap minus 6 by 7 k cap. Okay, let's move on to question number 9. Okay, so for question number 9, it's given that the position vector of the midpoint of line segment AB is 3i cap plus 2j minus 3k cap, and position vector of point A is given. We have to find the position vector of B. So there's a line segment joining A and B, and let's say this is our space with x, y, and z axis. Okay, now the position vector of point A with respect to O is given. Let's say it's A vector, and it's given as 3i cap plus 2j minus 3k cap. Okay, and let's say R is the midpoint of line segment joining AB, and the position vector of R is given. R is the midpoint, and position vector of R is 2i cap plus 3j cap minus 4k cap. We have to find the position vector of B, and let's say it's B. Okay, now we know that the position vector of midpoint is given by A vector plus B vector divided by 2. So R vector is equal to A vector is 3i cap plus 2j cap minus 3k cap minus 3k cap plus B vector divided by 2. Okay, and also the position vector of R is given, which is midpoint is given, which is 3i cap. So this is 3i cap. Okay, we have written wrong. This is position vector of midpoint, that is R is 3i cap plus 2j cap minus 3k cap, and A vector is 2i cap plus 3j cap minus 4k cap plus B vector divided by 2. Okay, this is now 6i cap plus 4j cap minus 6k cap, and it's 2i cap plus 3j cap minus 4k cap plus B vector, and the B vector is now 6 minus 2 is 4i cap, 4 minus 3j cap minus 6 plus 4 is minus 2k cap. So this is the position vector of point B, which is 4i plus j minus 2k cap. Let's move on to question number 10. Okay, for question number 10, we have to find the projection of vector 2i cap on vector 3i minus 2j cap. So let's say our vector is A is 2i cap plus 2j cap, and the next one is B vector. This is 3i minus 2j cap. Now projection of A on B is given by A dot B divided by B vector. Okay, let's find put in the respective values 2i cap plus 3j caps dot product with 3i cap minus 2j cap divided by magnitude of B, which is under root 3 square is 9 plus minus 2 square is 4. So 2 into 3 is 6 plus 3 into minus 2 is minus 6. Under root 13 is equal to 0. Under root 13 which is equal to 0. So this is A. Option A is the correct answer. Let's move on to question number 11. Okay, for question number 11, we have to find the equation of a line passing through point 111 and parallel to z-axis. And we know that equation of a line passing through a point and parallel to a given line is given by, so equation of a line passing through x1, y1, z1, and let's say parallel to given line is given by Cartesian equation is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. Okay, we know that the point is 1, 1, 1. So this equation is now x minus 1 upon a is equal to y minus 1 upon b is equal to z minus 1 upon c. Now what are a, b, and c? A, b, and c are the direction ratios. So we have to find the direction ratios. For that, let's try to understand the question. So it says that the line is parallel to z-axis and is passing through, let's say the point is 1, 1, 1. So we have got the equation here, but we don't know the A, B, and C, that's the direction ratio. Okay, so this line is parallel to z-axis, and so our parallel line is z-axis. So if this is parallel to z-axis, that means with uh, x and y, it makes it's perpendicular to x and y. So we know that a line, it makes an angle alpha with x-axis, beta with y-axis. So this is beta with y-axis and gamma with z-axis. So the direction cosines are L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. Now alpha, this line is parallel to perpendicular to x-axis, so alpha is 90, so L is equal to cos 90, and M is beta is the angle with y-axis, so it's also perpendicular to y-axis, so it's cos 90, and it's parallel to z-axis, so the angle with that axis is 0, that means the gamma is 0. So here the alpha is 90, beta is 90, and gamma is equal to 0, so we have got the direction cosines L, M, and N. So the direction cosines are 0, 0, and 1. But we have to find the direction ratios. So direction ratios are the multiples of some multiples of the direction cosines. So in this case, let's multiply them with 1. So the direction cosines can be the direction ratio. So in this case, it's 0, 0, 1. And we have multiplied this with 1. So it's 0, 0, 1. Direction ratios are 0, 0, 1. So if I put the value here, so our equation would be, this is 0, 0, and 1. So this is a required equation: x minus 1 by 0, y minus 1 by 0, then minus 1 by 1. So option D is the correct answer. Let's move on to question number 12. Okay, for question number 12, it's given if sum of the numbers obtained on throwing a pair of dice is 9, then probably the number obtained with one of the dice is 4 is. So let let's say E be an event where sum of numbers on a pair of dice is 9 is 9, and let F be the event where number on one of die is 4. So number on one of the dice is 4. Okay, so now what are the possible elements for which the sum of numbers on a pair of dice is 4 is 9 is either it's 4 5 5 4 6 3 3 6 7 3 6. So we don't have 7. Okay, so these are the possible pairs: 4 5 5 4 6 3 and 3 6. And now, so this is 3 6. Okay, now the number of one of the die should be 4, so F be the event, so we have 4 on these two. So this is 4 comma 5 or 5 comma 4. Now we have to find the number obtained on one of the dice is 4, that is we have to find F when E has happened. So that means this is, we know that this is equal to F intersection probability of intersection E divided by probability of E. So forming between these two intersection F is 4 5 and 5. Okay, now what is the probability of E? So probability of E, so total number of outcomes on throwing a pair of die is 36. So probability of E is, we have 4 elements, so it's 4 by 36, which is equal to 1 by 9. And what is the probability of E intersection F? So what is the probability of E intersection F? So probability of E intersection F. We have 2 elements, so this is 2 out of 36. So this is 2 by 36 divided by 1 by 9, which gives 9 fours are 36, and it's 1 by 2, which is equal to half. So D is the correct option, and let's move on to question number 13. Is for question number 13, we have to find the antiderivative of tan x minus 1 upon tan x plus 1. And antiderivative means we have to find the function for whose differentiation is tan x minus 1 upon tan x plus 1. So antiderivative is the reverse of the differentiation, which is integration. So we have to find the integration of tan x minus 1 upon tan x plus 1 in dx. Okay, now this is equal to negative of, I can take negative common, let me get this converted into some known form. And if I take negative common, this is 1 minus tan x, so this is equal to negative 1. And instead of 1, I can write tan pi by 4 minus tan x and 1 plus. So tan x, I can write it as 1 into tan x, and 1 can be replaced by tan pi by 4 into 10x. Now this formula is tan A minus tan B upon 1 plus tan A into tan B, which is equal to tan of A minus B. Okay, so this is now integration of tan of A minus B, which is x. So this is x into dx. Now integration of tan x. We all know integration of tan x is log of secant x. So this is now negative log of secant x, secant pi by 4 minus x, which has to be divided by differentiation of pi by 4 minus x is negative 1. So this gets cancelled plus c. And our answer for this is log of secant of pi by 4 minus x. So this is our option is C. And this solves our question number 13. Let's move on to question number 14. Okay, for question number 14, it's given that if A comma B, C comma D, and E, F are the vertices of a triangle, then determinant, and if determinant denotes the area of the triangle, then what is the square of this determinant? This is equal to what? 2 del square or 4 delta square or 2 delta or 4 net square. Now, we know that if a triangle has vertices x1, y1, so if the triangle has vertices x1, y1 and x2, y2 and x3, y3. Okay, so and then the area of the triangle is given by that is equal to half of this is, I can write it as x1, x2, x3, y1, y2, y3, and 1, 1, and 1. Okay, so this is how the area of the triangle is given by the determinant of half of the determinant of the vertices. So let's replace these values. So here the area of the triangle that is equal to half x1. So x1 is A, x2 is C, and x3 is C. So for x1 we have A comma B, for x2 we have C comma D, and for C we have E comma F. So x1 is its A, and x2 is C, and x3 is E. Now y1 is B, and y2 is D, and y3 is F. This is 1, 1, and 1. Okay, now, but our determinant is A, C, E, B, D, F, and we know that either we find out the determinant of A or either we find out the determinant of the transpose, it's all equal. So I can make the transpose of this. Let's shift to this side. So it's 2 delta is equal to, I can make the transpose because determinant of A is always equal to the transpose of A. So this is A, C, E, B, D, F, and 1, 1, 1. Okay, but it's given that it's asked in the question, what is the square of this delta? So that means we have to square on both sides. So a square on both sides will give it, this is the square. And if I square on this side, this gives me 4 determinant that square. So correct answer is option B for question number 14. It's 4 del square. Let's move on to question number 15. For question number 15, our function is f of x is equal to x into modulus of x. We have to check whether it's continuous and differentiable at x is equal to 0, continuous but not differentiable, differentiable but not continuous. So it's all about continuity and differentiability at x is equal to 0. So let's try to check it for the continuity and differentiability at x is equal to 0. And the function is f of x is equal to x into modulus x. Now we know that modulus of x is equal to negative x when x is less than 0 or x when x is greater than equal to 0. So this function now becomes this is x into negative x when x is less than 0 and x into x when x is greater than equal to 0. So this is equal to negative x squared when x is less than 0 and x squared when x is greater than equal to 0. So this is our function. So if we sketch it on the number line at x is equal to 0, so for less than 0, this is negative x squared, and greater than or equal to 0, this is x squared. So value of the function at 0 is equal to 0. Let's find its left hand limit. So this is limit x tends to 0 negative f of x, which is limit x tends to 0 negative x squared, which will give us 0. And similarly, right hand limit is equal to limit x tends to 0 plus f of x, and the function here is x squared, which will give us 0. So here the function's value at 0. So the value of the function at 0 is equal to left hand limit is equal to right hand limit is equal to 0. These coincide. So the function is continuous as at x is equal to 0. Now let's check it for differentiability. So for that, let's find out the left hand derivative, which is equal to limit h tends to 0 negative f of x plus h minus f of x upon h, and x here is 0, so this is equal to limit h tends to 0 for x is equal to 0. So this is f of 0 plus h minus f of 0 upon h. So f of 0 upon h is, this is f of h minus this is f of 0 and h. Now for left hand derivative f of h, so f of h is negative h squared, f of 0 is 0 by h, which gives us limit h tends to 0 negative h squared by h. This gets cancelled. This is limit h tends to negative h, which is equal to 0. Similarly, for the right hand derivative, so if I try to evaluate it for the right hand derivative, this is limit h tends to 0 positive f of x plus h minus f of x upon h. So x is equal to 0. So this is limit h right hand derivative f of 0 plus h is h minus f of 0 on h, and f of h for a right hand derivative is h squared minus 0 upon h, which gives us limit h tends to 0 positive h squared by h, which is equal to limit h tends to 0 positive h, which is equal to 0. So left hand derivative is equal to right hand derivative. Therefore, this function is differentiable at x is equal to 0. So this function is differentiable as well as continuous at x is equal to 0. So our option should be continuous and differentiable at x is equal to 0. So option A is the correct one. Let's move on to question number 16. For question number 16, we have to find differentiation of y with respect to x when tan of x plus y upon x minus y is equal to k. So it's given that tan of x plus y upon x minus y is equal to k. Now this can be written as x plus y upon x minus y is equal to tan inverse k. So this is now easy to differentiate. So differentiating this with respect to x, we are going to use the quotient rule here. So this is x minus y into differentiation of x is 1 and y is dy by dx minus, which is u into differentiation of v, which is 1 minus dy by dx upon x minus 1 the whole square is equal to 2. Tan inverse x differentiation is 0. So this is 0. And now let's open up these brackets. So it's x plus x into dy by dx minus y into dy by dx, and this is negative x, and so this would be plus x into dy by dx negative y and plus y to dy by dx is equal to 0. Okay, here this gets cancelled and x gets cancelled. So we have it's 2x into dy by dx minus 2y is equal to 0. So this is 2x into dy by dx is equal to y when it gets cancelled, and dy by dx is equal to y by x. So our option is option B for question number 16. And let's move on to question number 17. For question number 17, it's given that the objective function z, this is the function z, is equal to ax plus by. This has the maximum value 42. So it's given that the maximum value is 42 and that is at 4 comma 6. So for 4 comma 6, let's find out the value of z. So z is equal to a. So this is given that it's 42 at 4 comma 6. So z is equal to ax plus 4y. Now 4 comma 6 z is 42, which is maximum, and its x is 4, so this is 4a, and y is 6, so this is 6b. Let's say this is our equation 1. And now the minimum value is 19, so z has value 19, that is minimum at 3 comma 2, so this is 3a plus 2b. And solving these two equations will give us the value of a and b. So I'm going to write this equation as 3a plus 2b is equal to 19, and this is 4a plus 6b is equal to 42. And if I multiply this with equation with 4, so this gives me 12a plus 8b is equal to 4. 9 4s are 36 and 76. Okay, and let's multiply this with 3, which gives me 12a plus 6, 18 b is equal to 3 to the 6, 3 4s are 12. And if I subtract these equations, this gives me minus 10b is equal to minus 126 divided by 7. This is 12 minus 7 is 5. This is negative 50. So b is equal to 5. So b is equal to 5, and let's find out the value of a from any of the equations. So this gives us, if b is 5, so this gives us 3a plus 2 into 5 is 10 is equal to 19, and a is equal to 2 5s are 10, and 10, this is 19 minus 10 by 3, which is equal to 9 by 3, and is equal to 3. So a is 3 and b is 5. Let's check our options. So a is 3 and b is 5, so option C is the correct answer. Okay, so for question number 18, we have to find the corner points of the feasible region, and It's given that uh, the objective function is given, and we have to find the corner points of the feasible region are given, and for the objective function, we have to find the difference between the maximum and the minimum value. So let's find the value of the objective function at the given corner points. So let's find out the value. First corner point is 0, 4. So the value of the objective function at 0, 4 is equal to, it's 30 into 0 plus 24 into 4. So this is 0, so 4, 4, that's 16 and 96. Value of the objective function at 8 and 0. So this is 30 into 8 plus 24 into 0, which is equal to 240. And value of the objective function at 23 comma 4 by 3 is equal to, this is 30 into 20 by 3 plus 24 into 4 by 3. So this is 10 and this is 200. This is 8 for the is 32. So this is 232. So the maximum value is 240 and the minimum value is 96. So 240 minus 96 is 430 minus 9 is 4, 144. But we do not have any of the options here that says 144. So in this case, I would suggest to mark any of the options here, because if you have attempted the question only, then they may give you the marks, as they may not give you the marks if it's not in their notice. Okay, let's move on to the assertion and the reasoning based questions. Okay, for assertion and the reasoning based questions, these are the questions 19 and 20. Assertion is for question number 19. The assertion is that the maximum value of cos inverse x is pi squared. Now we know that the cos inverse x has the principal range uh, between 0 to pi, and the pi is the maximum value. So if I make the square of this, so it's saying that the maximum value of cos inverse x, so the maximum value is pi square, and if I make the square of this, so this is pi square. So the assertion is true. Let's check the range. The range of the principal value of branch is cos inverse x is minus pi by 2, which is wrong with because it's 0 to pi. So in this case, assertion is true and reason is false. Assertion is true, but R is false is the correct. So you can mark it for C. Okay, for question number 20, assertion if a line makes an angle alpha, beta, and gamma with the positive direction of coordinate axis. So it's given that a line is making an angle. So this is a line which makes an angle of alpha with x-axis, beta with y-axis, and gamma with z-axis. Now, we have to show that sine square alpha plus sine square beta plus sine square gamma is equal to 2. No. And for that, we know that the relation between the direction cosines L square plus m square plus n square is equal to 1. And L square is cos square alpha, m is cos beta, n is cos square gamma. Now cos square alpha, I can write it as 1 minus sine square alpha in terms of sine. This is 1 minus sine square beta, 1 minus sine square gamma is equal to 1. So 1 plus 1 plus 1 is 3. So this is 3, and if we take negative common, for sine square alpha, sine square beta plus sine square gamma, which is equal to 1, and this gives me sine square alpha plus sine square beta plus sine square gamma, which is equal to 3 minus 1 is equal to 2. So the assertion is true, and the sum of the squares of rational cosines of a line is 1. So this is the reason why we got this. So in this case, both A and R are true, and R is the correct explanation of A. So A is the correct option for question number 20. Let's move on to section B. Okay, for section B, this section comprises of very short answer type questions of 2 marks each, and we are going to solve the first one, both the parts. So for part A, we have to evaluate sine inverse sine 3 by pi by 4 plus cos inverse cos pi plus tan inverse 1. So this is sine inverse sine 3 pi by 4 plus cos inverse cos pi plus tan inverse 1. Okay. Now, 3 pi by 4, it does not belong to the principal range of sine inverse. It is minus pi by 2 to pi by 2. So we will have to get this into the range. So sine inverse sine 3 pi by 4 is, I can write it as pi plus pi by 4, or to understand it more clearly, let me write the value of sine 3 by pi by 4 in degrees, which is sine 135 degree. And cos inverse cos pi, this is in the principal range of 0 to pi, so this gets cancelled with its pi. And tan inverse 1, all we always pi by 4. Now sine 135 degree, we can write it as 180 minus 45. So this is pi, pi by 4, pi plus pi by 4. And 180 degrees pi, and pi by 4, it's 45. So this is 5 pi by 4, and this gets scared. Okay, now fine. So this is, now I can write it as sine, since it's sine pi minus pi by 4. We are in the second quadrant, and in second quadrant sine is positive. So this is sine pi by 4 plus 5 pi by 4. This gets cancelled. So we get this is pi by 4 plus 5 pi by 4, which is equal to 6 pi by 4, and that should be equal to 3 pi by 2. So for this, the answer is 3 pi by 2. Let's move on to the OR part, that is the part B, where we have to draw the graph of cos inverse x, and x is given. X lies between -1 to 0 close interval. So to draw the graph of cos inverse x, let's get our x and y axis, and it's very important to know what should be on the x-axis. The x-axis should depict what value, and the y-axis is going to depict what value of the cos inverse x. So x into y. Okay, if I write down this function, that is cos inverse x is equal to y. So this is our angle. So this is angle, and x is the numerical value. And the numerical value is -1 to 0. So the numerical value should lie on x-axis. Let's say this is 0, this is 1, and this is -1. And the angle should lie on y-axis. So this is, let's say, pi by 2 to pi, and negative pi by 2 pi. Okay, now let's draw the graph when x lies between -1 to 0, where -1 is included. So cos inverse -1, it's, let's say, is equal to y, and we know that cos is -1 when y is equal to pi. So that means this is our first coordinate, -1 to pi. And now let's check it for cos inverse 0. We know that cos is 0 when y is equal to pi by 2. So 0 comma pi by 2, this is our second coordinate, 0 to pi by 2, and let's join this. So this is our graph for cos inverse x. So this is our graph for cos inverse x, where x is -1 to 0. Now it's asks what is the rate. So rate of this function, it goes from, this is pi by 2 to pi. So the range is pi by 2 to pi, because for cos inverse x, the value is pi, and for 0, the value is pi by 2. So this goes from pi by 2 to pi. The range is pi by 2 to pi. And this solves our question number 21. Let's move on to question number 22. Okay, for in the question number 22, uh, a particle moves along the curve 3y is equal to ax cubed plus 1 such that at a point with x coordinate, y coordinate is changing twice as fast as x coordinate. So let's try to understand the question. And our curve is 3y is equal to ax cubed plus 1. And it's given that when x is equal to 1, dy by dx is equal to 2. Let's find out the value of dy by dx from the equation of the curve. So this is 3y is equal to ax cubed, and differentiating this with respect to x, we get dy by dx is equal to 3, it's 3ax square plus 0. So 3 and 3 gets cancelled, and dy by dx is equal to ax squared. Now, the value of the rate of change of y with respect to x when x is equal to 1 is a into 1 square, which is a. But this is given to us. It's given that when x is equal to 1, dy by dx is equal to 2. So this is 2, and a, so value of a is 2. For question number 23, it's given that if A, B, and C are three non-zero unequal vectors, so that means A is not equal to 0, A is not equal to 0, B is not equal to 0, and C is not equal to 0. Just remember that. And these are unequals, that is A, B, C, and are unequal, non-zero and unequal. Okay, now it's given that A dot B is equal to A dot C. And if I move this to the left hand side, so this is A dot B minus A dot C is equal to 0. And using the distributive property, over addition or subtraction, we can get this A dot B. I can write it as B minus C vector is equal to 0. Okay, so this gives me the dot product of two vectors is 0 when either A is 0 or B dot C 0. So either of them is 0, then also the dot product can be 0, but A cannot be 0 because it's given. B minus C is equal to 0 gives B dot C is equal to 0, B is equal to C, but B is not equal to C, it's also given. Okay, now the only option we are left with is when the dot product is 0 when these two vectors are perpendicular. So that means A vector is perpendicular to B vector minus C vector. That means angle between them. So angle between them is 90 degree. So this is 90 degree because these are perpendicular. For question number 24, we have to find the coordinates of points on line. Equation of the line is given in the Cartesian form, which is x upon 1 is equal to y minus 1 by 2 is equal to z plus 1 by 2. Now, this is the equation of the line, and we have to find the coordinates on the line which are at a distance, coordinates of a point on the line which are at, let's say this is the line. So this is the equation of the line, and we have any point which is at a distance from the origin, that is root 11. Let's say the point is P. Okay, now the given equation of the line is x upon 1 is equal to y minus 1 upon 2 is equal to z plus 1 upon 2. Let's say this is equal to k. Now x is equal to k and y minus 1 equating to k gives y is equal to 2k plus 1. So x is equal to k, and similarly z is equal to 2k minus 1. Okay, now for some value of k, there will be a point p whose distance from the origin is root 11. So let's say the general coordinates of the point, we let p point be k, and 2k plus 1 and 2k minus 1 be at distance of root 11 from origin. So that means the distance is OP, that is equal to root 11. And uh, let's find out the distance of OP using the distance formula. So we have the coordinates. This is x1, y1, z1, and these are x2, y2, x2, y2, and z2. And using the distance formula, this will give me, this is k minus 0 the whole square plus 2k plus 1 minus 0 the whole square plus 2k minus 1 minus 0 the whole square is equal to root 11. So we have used the distance formula. So if I square on both sides, so square on both sides will take off the square roots. So this is now k square, and this is 2k plus 1 minus 0 is 2k plus 1. So this is a square plus b square plus 2ab, and this is also a square plus b square minus 2ab is equal to 11. And k square plus 4 square plus 4 square, this is 9k square, 4k minus 4k gets cancelled, plus b is equal to 11, so 9k square. So this is 2 plus 1 is 3, and 11 minus 3 is 8. So we are missing something here. It's 2k square, which is 4k square. This is 1. And 1 plus 1 is 2. So this is 2. And 11 minus 2 is 9. So k square is equal to 1, and k is equal to plus minus 1. Now, let's find out the value when k is equal to 1, x is equal to 1, y is equal to 3, and z is equal to 1. So coordinates are 1, 3, and 1. And when k is equal to negative 1, x is equal to negative 1, y is equal to 2 into negative 1 is minus 2 plus 1 is minus 1, and z is equal to 2 minus 1 is minus 2 minus 1 is minus 3. So the coordinates are minus 1, and minus 3. So 1, 3, 1, and minus 1, minus 3 are the coordinates of the point. And this solves our question number 24. Let's move on to the next one. So these are the coordinates, required coordinates of the point. Okay, we are on to question number 25. And for the first part, it's given the function is y is equal to under root ax plus b, and we have to prove that y into second order derivative plus square of the first order derivative is equal to 0. So let's write down our function first. The function is y is equal to under root ax plus b. Okay, this is our function, and to eliminate root, we can square on both sides. So square on both sides gives us square of y is y square, and the square of right hand side is, this is equal to, now y square is equal to ax plus b. Okay, let's differentiate this with respect to x. So differentiating with respect to x, we get Okay, now differentiation of y square is 2y and y is dy by dx, and differentiation of ax plus b. B is a constant, a and b are constant, so a is out and differentiation of x is 1. And yes, we have to get the second order derivative, so let's differentiate it once again. Let's take 2 common, and this is u into v, so it's v into differentiation of y, which is again dy by dx plus dy by dx into differentiation of y, sorry, y. So this is second function into differentiation of first plus first into differentiation of second function, which is dx square by dx square. So this is the second order derivative, and the differentiation of constant is 1. Okay, now, okay, the differentiation of constant, sorry, is 0. So this is 0. Now 2 when shifted to this side is also 0. So finally we can write it as this is y into the second order derivative plus, and this is the square of the first order derivative, which is equal to 0. And that's what we have to prove. So we are done with the part A. Now let's move on to part 2. So for the second part, it's given that the function is differentiable in open interval 0 to 2. And let's write down the function first. So the function f of x is equal to, this is ax plus b upon, sorry, ax plus b. So the function is ax plus b when x is greater than 0 but less than equal to 1. And this is 2x square minus x when x is greater than 1 but less than 2. Okay, now the function is differentiable in 0 to 2. So that means it's also continuous in 0 to 2. So given function is differentiable in 0 to 2. So that means function is also differentiable at x is equal to 1. And as the function is differentiable in 0 to 2, so that means the function is continuous on 0 to 2. So that means that the function is continuous. 0 to 2 means function is continuous at x is equal to 1. So let's try to use these two conditions. So when the function is differentiable at x is equal to 1, that means this will give us that left hand derivative is equal to right hand derivative at x is equal to 1. So let's find out the left hand derivative. So left hand derivative is limit x. So we will evaluate it for the limit h, and its left hand derivative. So this is f of x plus h minus f of x upon h. And the right hand derivative is limit h tends to 0 plus, this is f of x plus h minus f of x upon h. Okay, now for the left hand derivative, so our function is on the number line, it looks like this. So this is, let's say, 0, 1, and 2. So between 0 and 1, the function is ax plus b at x is equal to 1. The function value is ax plus b. And between 1 and 2, it's 2x square minus x. So because we are differentiating it at x is equal to 1, so the left hand derivative for that the function is ax plus b. So the function is ax plus b for left hand derivative, it's ax plus b, and its x is equal to 1. So this is now limit h tends to 0, negative x is 1. So f of 1 plus h minus f of 1 upon h. Now, so the function for left hand derivative is ax plus b, and f of 1 plus h will be equal to a into 1 plus h plus b. So let's replace the value here. So, sorry. So this is limit left hand derivative. Okay, this is limit h tends to 0 negative f of 1 plus h is a into 1 plus h plus b, and f of 1, so let's put the value 1 here, so this will be a plus b upon h. And now let me raise this. Okay, so let's evaluate this. So if I open up the bracket, so this will give me a plus ah plus b minus a minus b upon h. So b and b gets cancelled, a and h gets cancelled, because this is limit h tends to 0 negative a h upon h. So we are left with a, so this is equal to a. Okay, so this is, let's say, equal to a. Okay, now let's find out the right hand derivative. So right hand derivative is equal to, this is equal to limit h tends to 0 positive. Now for the right hand derivative, our function is 2x square minus x, and f of x plus h, x is 1, so this is f of 1 plus h minus f of 1 upon h. So which is equal to limit h tends to 0 positive, f of 1 plus h, so this is 2, instead of x we have to write 1 plus h, this is 1 plus h, so this is 2 into 1 plus h the whole square minus 1 plus h. And function's value at x is equal to 1, that would be 2 minus 1 upon h. Okay, so let's open up the bracket. So this is, okay, so this is 2 plus h square. So this is 2h square. I'm opening up the bracket and at the same time multiplying it with 2. So this is 2h plus 4h minus 1 minus h minus 1 upon h. And finally, we have its limit h tends to 0 positive. This is uh, 2 minus 1 is 1, so this gets cancelled with 1, and finally we have 2h square plus 4h minus 1. Let's take h common, so this is 2h plus 4 minus 1 upon h and h gets cancelled, which is equal to limit h tends to 0 positive, and this is 2h plus 3. So if we use a limit now, so this is equal to 2 into 0 plus 3, which is equal to 3. So a is equal to 3. Okay, we have find the value of a, and we have just used the condition of the left-hand derivative. So we have used the condition of the function is differentiable at x is equal to 1, where we created the left-hand derivative is equal to right-hand derivative. Let's use the condition where x is equal to 1. So when x is equal to 1, so that means at x is equal to, so function is continuous at x is equal to 1, so that means at x is equal to 1, so at x is equal to 1, left hand limit is equal to right hand limit is equal to function's value at 1. Okay, now our function, this is at x is equal to 1, left hand limit will be, so limit x tends to 1 negative, and the function is ax plus b, and the right hand limit is limit x tends to 1 plus, and the function's value is 2x square minus 1. Now the function value at x is equal to 1. At x is equal to 1, it's again ax plus b. So this is ax plus b. So at x is equal to 1 and the left hand limit it's equal. So we are going to create the ax plus b. So the function's value at f of 1, so let's put in the value of x here 1, which is a plus b. So a plus b is equal to, let's evaluate. So this and this are equal. So we are going to use the right hand limit. with the function's value and right hand limits, its limit h tends to 0. Let's say for right hand limit, let's say x is equal to a small value greater than 1. So as x tends to 1, h tends to 0. So this is h tends to 0, and this is 2 into this is 1 plus h the whole square minus x is 1 plus h upon, okay, that's all. And this is now limit h tends to 0. And if I put in the value of h is 0. So this is 2 minus 1. If we evaluate it for the limit, so this will be 2 minus 1, which is equal to a plus b. So a plus b is equal to 1. But we have already got the value of a, which is 3. So that gives me 3 plus b is equal to 1, and b is equal to negative 2, and a is equal to 3. So b is equal to negative 2 and a is equal to 3. That solves our question number 25. And let's move on to section C. Okay, for question number 26, we are on to section C, and this section comprises short answer questions of 3 marks each. For the question number 26, first part, we have to evaluate definite integral 0 to pi by 4 log of 1 plus tan x into dx. So let's say it's our integral I, and we have to evaluate for 0 to pi by 4. This is log of 1 plus tan x into dx. Okay, now here first of all we are going to use the property it's 0 to a f of x into dx, which is equal to, we can write it as 0 to a f of a minus x into dx. So this gives I is equal to now 0 to pi by 4, and instead of x we are going to replace it with a minus x, and a is pi by 4. So this is log of 1 plus tan of pi by 4 minus x into dx. Okay, so now this is the formula tan a minus b. So tan of a minus b is equal to tan a minus tan b upon 1 plus tan a into tan b. Now, so I is equal to 0 to pi by 4, and let's consider this as our first set of equation. So this is log of 1 plus, let's use tan a plus b here. So this is tan a, which is pi by 4 minus tan b upon 1 plus tan of pi by 4 into tan b, which is x. Okay, now I is equal to 0 to pi by 4 log of 1 plus tan pi by 4 is 1, and tan x, which is 1 plus tan pi by 4 is 1, so it is tan x. Let's take LCM here. So I is equal to 0 to pi by 4, and this is log of 1 plus tan x and 1 plus tan x plus 1 plus tan x. This gets cancelled. So finally, this is 0 to pi by 4 log 2 upon 1 plus tan x. Let's say this is our second set of equation. We are going to add 1 and 2. So I plus I is 2i, and limit is same 0 to pi by 4, which gives, so the first set of equation was log of 1 plus, it was log of 1 plus tan x. So this is 1 plus tan x, and plus this is log of 2 upon 1 plus tan x. Okay, and now this is log A plus log B. So log A plus log B, we all know it's log A. So 2I is equal to 0 to pi by 4, and this is now log A into B. So log A into B is log A, and this is B 2 upon 1 plus tan x. This gets cancelled, and we are left with 2. This is x. So 2I is equal to 0 to pi by 4 log 2 into dx. Log 2 is constant, so this is out. And now this 0 to pi by 4, 1 into dx. Integration of 1 is x, so this is 2I is equal to log 2 and x for the limits 0 to pi by 4, which is pi by 4 into log 2. And finally, I is equal to pi by 8 into log 4. So this is our answer. Let's move on to the second part. We have to evaluate the integral. It's input integral. So our integral is I is equal to integration of dx minus under root sine cube x into cos of x minus alpha into dx. Okay, we are now we are here going to make some adjustments because it's not in standard form to be differentiated yet. So in this root, we are going to multiply and divide it by sine x, all within the root. So this is integration of dx, and this is integration of, we are going to multiply sine cube x into cos of x minus alpha. So multiply and divide by sine x. Now sine x into sine cube x. So this is now integration of sine raised power 4x into cos x minus alpha. And this is all within the root. Okay, now root of sine raised power 4x is sine square x. So this is integration of sine square x is out, and under root we have, so 1 by sine x. So this is cos of x minus alpha upon sine x. That is all within the root. Now sine square 1 upon sine square x, I can write it as integration of cosecant square x into dx. And I'm going to use the formula cos of a minus b here, which is cos a cos b plus sine a sine b upon sine x, and this is all within the root. Now, so our integral is now integration. This is cosecant square x into dx, and this becomes cos by sine is cot x. So this is cot x into sine x, and sine by sine gets cancelled. So this is only sine alpha here. This is under root. Okay, now it's now in the standard form where we know that the differentiation of cot is cosecant square, and we are going to assume this. We are going to make the substitution. So let's say cot x into sine x plus sine alpha is equal to 2. So differentiation of cot x, this is actually cos x by sine. This is, here it should be cos alpha. So this is cos alpha. Okay, now different cos alpha is constant, so it's out, and differentiation of cot is negative cosecant squared dx is equal to dt. Sine alpha is constant, so differentiation is 0. So that means cosecant square x into dx is equal to minus dt by cos alpha. Our integration after substitution now this negative is out and cosecant square into dx is dt. Cos alpha is constant, so it's 1 by cos alpha, and this is under root d. And we know that the difference in integration of the under root d is 2 root d. So this is 2 root d plus c. And finally, we can replace the value of d, which was cos x into cos alpha plus sin alpha upon cos alpha plus c. And this is our integration. Okay, so this was our question number 26, and let's move on to question number 27. Okay, for question number 27, we have to find the integration of, so our function is integration of e raised power cot inverse x into 1 minus x plus x square upon 1 plus x square into dx. Okay, first of all, let's try to eliminate this cot inverse x, and let's try to make it a substitution tree. So this, if cot inverse x is equal to t, this gives us uh, cot t is equal to x. Now differentiation of cot inverse x is minus 1 upon 1 plus x square into dx is equal to dt. So dx upon 1 plus x square is equal to negative dt. So that means this term is now negative dt. Okay, let's make the substitution. So our integral is e raised power t into 1 minus x. X is cot t plus x square is cot square t, and dx upon 1 plus x square is negative, and now integral element is dt. Okay, so this is now negative of e raised power t, and 1 plus cot square is cosecant square t minus cot t into dt, because 1 plus cot square is cosecant square t. Now this is of the form integration of e raised power x into f of x plus, okay, not yet. Let's multiply it with negative. So this gives me e raised power t into cot t negative of cosecant square into t. Now this is of the form e raised power x into f of x plus f dash x integration, and which gives us e raised power x into f of x plus c. So if we use this, so finally our integration is e raised power 2, this is f of x, and this is f dash x. F dash x is negative minus cosecant square. So we can also write it as, I can write it as, let's put it positive, and now this is, so differentiation of cot is minus cosecant square t. So this is function and this is its differentiation, and we have used this formula. So this gives me e raised power x, f of x is cot t plus c. Let's find it. You substitute the value of t, which was cot inverse t, and cot t was x. So this is x into cot inverse x, sorry. So this is cot inverse x. So it's cot inverse x, and this is the integration of question number 27. Let's move on to question number 28. For question number 28, we have to find the integral, infinite integral with the limits log root 2 to log root 3. Let's try to get it simplified first, and evaluate it without the limits. So I is equal to, let's say it's 1 upon e raised power x plus e raised power negative x into e raised power x minus e raised power negative x into dx. And let's try to simplify it first. This is 1 upon e raised power x plus 1 upon e raised power x and e raised power x minus 1 upon e raised power x into dx, which gives us, so this is, let's take LCM here, and this is e raised power x squared, which is e raised power 2x plus 1 upon e raised power x. This is e raised power 2x minus 1 upon e raised power x into dx. So e raised power x into e raised power x is e raised power 2x, so which goes up, and this is a plus b into a minus b, which is a square minus b square. Okay, now let's make the substitution here, and our limits are log root 2 to log root 3. So this is log root 2 to log root 3. Now let's make the substitution for this. So this is e raised power 2x is equal to 2, and differentiation of e raised power 2x is e raised power 2x, and differentiation of 2x is 2 into dx is equal to dt. So this gives us e raised power 2x into dx is equal to dt by 2. And because we have to make the substitution, so let's get new limits as well. So when x is equal to log root 2, then t is equal to e raised power 2 log root 2, and this can be written as log root 2 square. So this is e raised power log 2, which is equal to 2. So when x is equal to 2, t is equal to 2. And similarly, when x is equal to log root 3, t is equal to 3. So finally, our new integral with the new limits is 2 to 3. So this is 2 to 3, and e raised power 2x into dx is dt by 2. So this half is out. This dx is now dt and e raised power 2x. So this is t square minus 1 square. Okay, so this is t square minus 1 square, and for this we are going to use the integration of, this is of the form dx upon x square minus 1 square, which is 1 by 2a into log of x minus a upon x plus a. So if we use it here, so this is now half into 1 by 2a, this is 1 by 2 into a is 1. So log of t minus 1 upon t plus 1, and this has to be evaluated for the limits 2 to 3. Okay, so this is 1 by 4 log of, now if you put 3, so this is 3 minus 1 is 2, 4, and minus log of 2 minus 1 is 1, 2 plus 1 is 3. This is 1 by 4 log of a minus b, which is log of a upon b. So this is actually half, which gives us 1 by 4 log of 3 by 2. And this is the answer, that is integral is equal to 1 by 4 log of 3 by 2. And let's move on to the next one, question number 29. Before question number 29, we have to find the general solution of the differential equation. And we'll try to solve both the parts A and B. So let's try to get the differential equation in some known form. It's xy minus x squared into y is equal to y square into dx. Okay, by dividing it by dx on both the sides, this gives me, or let me just bring this to the left hand side and take this to the right hand side. So this is y square upon xy minus x square. Now divide it with x square on both the sides. So this is y square by x square upon xy upon x square minus x square upon x square. So this gets cancelled. And now this is y upon x is v. Okay, so it's not v, we haven't made substitution. So this is y upon x, the whole square. And this is y upon x minus 1. Okay, now let's make the substitution here. Let's say y upon x is equal to v, which gives us y is equal to vx, and differentiating with x on both the sides. So differentiating with respect to x, we get this is dy by dx, and v into differentiation of x is 1 plus x into differentiation of v, which is dv by dx. So let's say this is equation 1, this is equation 2, and from 1 and 2 we get, so we can write from 1 and 2 v plus x into dv by dx, which is equal to y by x is v, so this is v square upon v minus 1. And this is x into dv by dx, which is v square upon v minus 1 minus v. And if we take LCM, v minus v, which is v square minus v into v minus 1. So this is now dv by dx is equal to v square minus v square plus v upon v minus 1. This gets cancelled. This is x. And separating the variables gives us v upon v minus 1 into dv is equal to dx upon x. Now integrating on both sides, so I can write it as 1. Okay, this is actually v1 minus, so this is v minus 1 by v into dv, so which gives 1 minus 1 by v into dv is equal to, this is log x plus c. Now integration of 1 is v, integration of 1 by v is log v, which is equal to log x plus c. Now v is 1 by x, log v is y by x is equal to log x plus c. This is the general solution of the given differential equation. Let's try to solve the second part as well. We have to find the general solution of the differential equation, and we will try to get this converted into a standard form. And it's given that it's x squared plus 1 into dy by dx plus 2xy is equal to under root x squared plus 4. Okay, let's try to eliminate this x squared plus 1. So dy upon dx plus 2x into x squared plus 1 into y is equal to, this is x squared plus 1 or x squared plus 4 under root, and this is x squared plus 1. Now this seems to be of the form dy by dx plus py is equal to 2. This is equation 1 and 2. So if we compare 1 and 2, so if we compare equation 1 and 2, this gives us p is equal to 2x. So p is equal to 2x upon x squared plus 1, and the q is equal to under root x squared plus 4 upon x squared plus 1. And let's try to find out the integrating factor. So integrating factor is, this is now e raised power integration of p into dx, which is integration of p. P is 2x on x squared plus 1 into dx. Now, so this is f dash x, and this is f. And we know that integration of f dash x upon f of x is log of x. So this is e raised power log of x squared plus 1. So we are done with the integration. So this is integration of log of x squared plus 1, which is equal to x squared plus 1. So our integrating factor is x squared plus 1. And we know that the general solution of such form is given by its y into integrating factor is equal to integration of q into integrating factor into dx. Now this is y into integrating factor is x squared plus 1. This is integration of q. Q is under root of x squared plus 4 upon x squared plus 1 into integrating factor is x squared plus 1. So this gets cancelled. And y into x squared plus 1 is equal to integration of this of the form x squared plus a squared. So I can write it as a square. And for this, we know the formula of x squared plus a squared. We know that under root of x squared plus a squared into dx is equal to x by 2 under root x squared plus a squared plus a squared by 2 log of x plus under root of x squared plus a squared plus c. So if we apply this formula here, so this gives us y into 1 plus x squared, which is equal to x by 2. So this is x by 2, x squared plus a squared is x squared by 4 plus a squared. A squared is 4, which is 4 by 2 is half log of x plus under root of x squared plus a squared, which is 4 plus c. So this is our equation y into 1 plus x squared x by 2 into under root of x squared plus 4 plus this is actually a square is 4, so 4 divided by 2 is 2, and we can write it as simply 2. So this is 2 log x plus under root x squared plus 4 plus c, and this solves our question number 29 as well. Let's move on to question number 30. For question number 30, it's given that the two balls are drawn. This is the part A. Two balls are drawn at random one by one with replacement from an urn containing equal number of red and green balls. And if you have to find the probability distribution of number of red balls, and also we have to find the mean of the random variable. So there are equal number of the red and green balls. So this is question number 30, part A. And let's say number of red balls is equal to number of green balls. Let's say this is x. Okay, so so number of red balls is x and number of green balls is x. So total balls in the urn is green plus red, which is equal to 2x, and probability of drawing a red ball is equal to x upon 2x, which is half. and probability of drawing a green ball is also half. Okay, now it's given that we have to draw two balls at random one by one with replacement. So the total number of balls in the urn remains same, and we have to find the probability distribution of number of red balls. So if we draw two balls, then if we do draw two balls and either none of them is red, so that means either it's zero, the number of red balls is zero, or either one of them is red, so that means either one of them is red or both of them are red. So let's say x be a random variable that denotes number of red balls. So x is a random variable, so that means x can take the value 0. None of them is red ball, either one of them is red or both of them is red. Now let's get the probability of none of them is red. That means first ball is green, and so that means first ball is green and also second ball is green. Now the probability of green is half and half, which is 1 by 4. So probability that none of the ball is red is 1 by 4. And what are the ways in which either one of them is red? So either the first ball is red and the second ball is green, or the first ball is green and the second ball is red. So probability of red is half into half plus half into half, which gives 1 by 4 plus 1 by 4, which is half. Now, probability that both of them are red, that means the first ball is red and the second ball is red. So this is red. So both of them are red, and probability of red is half into half, which is equal to 1 by 4. Okay, now our random variable was 0, 1, and 2, and their respective probabilities. Probability of 0 was 1 by 4, probability of 1 was half, and probability of 2 red balls is 1 by 4. Now, okay, this solves our first statement, and it's also asked to find the mean of the random variable. So we denote the mean of the random variable by E of, that is the mean of the random variable, and that is summation of EI into XI. That is probability when X is 0. So we have to do the product and then add them. So do the product and add them. So this is 0 into 1 by 4 plus half, 1 into half, plus this is 2 into 1 by 4. So 0 into 1 by 4 is 0. This is half, and this is also half. So half plus half is 1. So the mean of this is 1. Okay, let's move on to the B part. It says that A and B throw a die alternately till one of them gets a 6 and wins the game. So getting a 6 will make that participant win the game. So we have to find the respective probabilities of winning if A starts the game first. Okay. So in this case, because a die is thrown alternately by the two participants A and B, and one who gets 6 first will win the game. So we have to find the respective probabilities of winning if A starts the game first. So if a die is thrown, then probability of getting a 6 is 1 by 6. And probability of not getting a 6 is 5 by 6. So probability of not getting a 6 is 5 by 6. Now, let's say it's given that A starts the game. So probability of A winning the game. So it's possible that A throws a die and on the first throw he gets a 6, so he wins. So it's like probability of A winning the game is a probability of A getting the 6, that is 1 by 6. Now, if so, this is the first case. Now, if A doesn't get 6 on the first row, that means 5 by 6 not getting a 6. Now we have to make sure that the A wins. So now B is going to throw the die, and he's also not going to get 6. So this is 5 by 6. And now comes the turn of the A and he wins. So this is 1 by 6. Similarly, A doesn't win the game, B doesn't win the game, then the other possible way could be A doesn't win the game, B doesn't win the game, and now A wins the game. So this goes on like this. So this is 1 by 6, and this is 5 by 6, the whole square into 1 by 6 plus 5 by 6 raised power 4 into 1 by 6, and this goes on till infinity. And if you have a close look at this series, this is an where A is equal to 1 by 6 and the common ratio is 5 by 6 the whole square, and which is equal to 25 by 36. So here R is less than 1, and we know that to find the sum of the GP till infinity, formula is A, and because R is less than 1, 25 by 36 is less than 1, this is a common ratio. So this is 1 minus. So let's get the sum of this, which is A is 1 by 6, the first term, 1 minus 25 by 36, which gives 1 by 6, and this is 36 upon 36 minus 25, which is equal to 1 by 6 divided by 36 minus 25 is 11 by 36, which gives us 1 by 6 into 36 by 11. So the probability of A winning the game is 6 by 11. Now, to find the probability of B winning the game, it's easier because we have got the probability of A winning the game. So probability of B winning game is equal to 1 minus probability of A winning the game. So this is equal to 1 minus probability of A winning the game is 6 by 11. So this is equal to 11 upon 11 minus 6, which is 5 by 11. Okay, so this solves our question number 30 for both the parts. Let's move on to question number 31. Okay, we are on to question number 31, and this problem is based on linear programming module. We have to solve the following linear programming problem graphically. We have to sketch the graph, and its objective function is z. So its objective function is z, that is minima. So this is minimum z is equal to 5x plus 10y. And now it's subject to the constraints. We have the inequality equations x plus 2y is less than equal to 120, and x plus y is greater than equal to 60, and now x minus 2y is greater than equal to 0, and x is greater than 0, y is greater than 0, obviously. Okay, to solve this problem graphically, we have to sketch the graph of these inequalities, and for this we are going to sketch it for the linear equation. So our first equation is x plus 2y is equal to 120, and let's get the coordinates. So if x is equal to 0, which gives me y is equal to 60, and if y is equal to 0 gives me x is equal to 120. So these are the coordinates of the first one, And for the second one, it's x plus y is equal to 60. And if x is equal to 0, y 60, when y is 0, x is 60. So these are the two coordinates of the second equation. This is first and second. And the third one is x minus 2y is equal to 0, which gives me if x is 0, then y is 0. And let's put in some other value for it. Let's say if x is 20. So if x is 20, then y is 10. But let's say if x, let's put x is equal to 40. So if I put x is equal to 40, so this is 40 minus 2y is equal to 0, which is minus 2y is equal to minus 40, and y is equal to 20. Okay, so let's sketch the graph for these three equations, and then we will check for the solution region using these inequalities. And for that, let's get the x and the y-axis. And let's try to get it on the grid. Okay, and then we are going to use the units. Let's say it's 10, 20. So this is 20 and 40. And it's 20, 40, 60, 80, 100, 120, 140. Okay, similarly on the y-axis, it's 20, 40, 60, 80, 100, 120, and 140. Okay, let's sketch the graph for x plus 2y is equal to 120. So it's 0, 60, which is here, and 120, 0. So this is here. So let's join this. Okay, so this is the graph for x plus 2y is equal to 120. And it's given that x plus 2y is less than equal to 120. And if we try to check it for 0 comma 0, so this gives me 0 is less than 120, which is true. So that means a graph of this equation is towards the origin. The solution region is towards the origin. Okay, for the second one, it's x plus y is equal to 0, so 0, 60. So 0, 60 first is this, and then 60, 0. So the second point is this. And if we join them, so this is now, okay. So this is the graph of x plus 6y is equal to 60. Okay, the third one is x minus 2y is equal to 0. So it's 0, 0 going through the origin. This is 0 comma 0. This is 0, 60, 120, 0, and 60, 0. Okay, this is 0, 0, and 40, 20, 40, 20. So this is 40 and 20. So it goes to 40, 20. And if I sketch the graph for this, it goes through the origin and then it goes like this. Okay. Now for both these uh, inequality, this is x plus y is greater than equal to 60. So if I check this, x plus 6y is greater than equal to 60. So for 0 comma 0, this is false. So this has the solution region away from the origin. And this one, this is the graph of x minus 2y is equal to 0, and its inequality is x minus 2y is greater than equal to 0. And let me just take this point 60 comma 60. So if I check this for 60 60 for this equation, this gives me 60 minus 2 into 60 is greater than 0, which is 60 minus 120 is greater than 0, minus 60 is greater than 0, which is false. So if so, that means the graph of this is towards its downward, and for this it's towards the origin, and for this it's away from the origin. So we have our solution region. This is our physical region. So this is our physical region. I'm going to color it with yellow. Okay, now let's get the corner point. So this point is obviously 40 and 20, and this point seems to be 60. This point, it seems to be 60 and 30. So this is 60 comma 30, and this is 120 comma 0. So let's write down our corner points. So our corner points are four corner points. So let me just write down the corner points and get the respective value of the function at those points. So our corner points are, first one is it's 40 20. Second one is 60 30, and then 120 0, and then 60 0. Okay, let's get the value of the function, and the function is 5x plus 10y. So this is 5x plus 10y. For this, it's 5 into 40 plus 10 into 20. This is equal to 200 plus 200, which is equal to 400. And now this is 5 into 60 plus 10 into 30, which is 300, plus 300 is equal to 600. This is 5 into 120 plus 10 into 0, and this gives me 5. 12 into 5 is, this is 600. Okay, for the last one, it's 5 into 60 plus 10 into 0, which is equal to 300. Now the minimum value here, this function has to be minimum, and the minimum value is 300. So minimum value of z is 300, and that is at 60 comma 0. So that's what was asked in the question. So we have to solve it graphically, and graphically we got the four corner points, and for all the four corner points, the minimum value is at 60 comma 0. So this solves our question number, the minimum value is 300, and this solves our question number 31. Let's move on to the next section. Here we are on section D, and this section comprises of long answer type questions of 5 marks each. Let's get started with the first one, part A. And it's given that A and B matrices are given. We have to find AB. and then use it to solve the following system of equations. That is, first find out the product of A and B. So let's write down the A matrix. So this is minus 3, minus 2, 4, 2, 1, 2, 2, 1, 3. So this is A, and now B is equal to 1, 2, 0, minus 2, minus 1, minus 2, and 0, negative 1, 1. We have to find the product. So let's find the product AB. And so this is first row and first column. Minus 3 into 1 is minus 3, negative 2 into negative 2 is plus 4, minus 4 into 0 is 0. First element, and minus 3 into 2 is negative 6, plus 2, plus 4. Minus 3 into 0 is 0, minus 2 into minus 2 is plus 4, and negative 4. This is the second row and first column, so 2 into 1 is 2, 1 into minus 2 is minus 2, 2 into 0 is 0. So plus 0 now, 2 into 2 is 4, 1 into minus 1 is negative 1, 2 into minus 1 is negative 2, 2 into 0 is 0, minus 2, and 2 into 1 is now third row and all the columns. So 2 into 1 is 2, 1 into minus 2 is minus 2, 3 into 0 is 0, 2 into 2 is 4, 1 into minus 1 is minus 1, 3 into minus 1 is minus 3, 2 into 0 is 0, 1 into minus 2 is minus 2, plus 3. Okay, so this is now minus 3 plus 4 is 1, 6 is 0 and 0. Okay, so this is 0, 4 minus 1 is 3, minus 2 is 1, this is 0, 0, 4 minus 1 is 3, minus 3 is 0, and this is 1. Okay, so we have got AB. Okay, so which is an identity matrix? So that means A and B are, so A and B are convertible matrix because the product of them is an identity matrix. So A and B are convertible matrices. And when A and B are convertible matrices, that means they are inverse of each other. So A inverse is B and B inverse is A. So that is the result we got from the product. And now we have to use this concept to solve these equations. And let's write down the given system of equations are. So given system of equations are, first is x minus 2y is equal to 3. And then 2x minus y minus z is equal to 2. 2x minus y minus z is equal to 2. And then it's minus 2y plus z is equal to 3. So minus 2y plus z is equal to 3. And these given of system of equations, these can be written in the form. These equations can be written in the form. So this is Cx is equal to D, where C is, so C matrix is 1 minus 2 0 and 2 minus 1 minus 1. This is 0 minus 2 and 1. So this is C, and X is equal to, so X, so X, or so these matrices can be written in the form Cx is equal to Z B and X is equal to C inverse D. Now let's write down the C matrix. So C matrix is 1 minus 2 0 and 1 minus 1 minus 1. This is 0 minus 2 and 1. So we have to get the inverse of this into D is D matrix is 3, 2, and 3. Okay, now if we have a close look at the C matrix, that is 1 minus 2 0, and B matrix. So if we check the B and the C matrix, so this is C and this is B. So both these are, so C matrix is actually the transpose of B. So C matrix is 1 minus 2 0, 1 minus 1 minus 1 0 2 0. So C matrix is actually the transpose of B. So instead of C here, I can write B transpose and then inverse into B. Now this B transpose can be written as B inverses transpose. So this is transpose, and C is equal to transpose of B. So instead of C, I have written B transpose, and B transpose inverse can be written as B inverse transpose. Now B inverse is equal to A. So instead of B inverse, I can write the A matrix, and A matrix is, this is minus 3 minus 2 minus 4 and 2 1 2 and 2 1 3. So this is the B inverse. So B inverse is equal to A. So instead of B inverse, I'm going to write A and then use the transpose. So it has to be the transpose here. So this is A transpose into D. So this is A, and we will do its transpose and then multiply it with D. D is 3, 2, and 3. So that's how we are going to use this result. So I have just written here to show that this C matrix, this one, is the transpose of B. So instead of C, I have written B transpose and then its inverse. And now B transpose inverse can be written as B inverse transpose. So B inverse is A. So it's A transpose into D, and A is 3 minus 2 minus 4. So let me do its transpose now. So it's minus 3, 2, and minus 2, 1, 1, and minus 4, 2, 3. So this is now the transpose of A. We have to multiply it with 3, 2, 3, and that will give me X. X is X, Y, and Z. So this is X. Okay. So let's multiply this, and this is minus 3 into minus 3 is minus 9. 2 into 2 is 4 plus 6. Next one plus column. So minus 2 into 3 is minus 6 plus 2 plus 3, and it's minus 12 plus 4 plus 9. And this is X, Y, and Z. Okay, so this is minus 9 plus 4 is minus 9, minus 5 plus 6 is 1, minus 6 plus 2 is minus 4 plus 3 is negative 1, and minus 12 plus 4 is negative 8 plus 9 is 1. Okay, this gives me X is equal to 1, Y is equal to negative 1, and Z is equal to 1. So these are the values of X, Y, and Z. And that's how we use the product to get these, show that the matrices are convertible and A inverse is equal to B, B inverse is equal to A. Now these equations, write them in the matrix form, which gives me X is equal to C inverse of B, and C is actually the transpose of B. So we have written, instead of C, it's B transpose, and B transpose inverse is B inverse transpose, so B inverse is A. So B inverse is A, so A transpose into D, write down A transpose it and multiply it with D, which will give us the value of X, Y, and Z. Okay, now let's move on to the next part of this question. And first of all, I'm going to erase this. Okay. For the part B, it's given that function f alpha is in terms of matrix. So it's given that f alpha is equal to cos alpha minus sin alpha into 0 and 0. So this is sin alpha cos alpha 0 and 0, 0, 1. Okay, we have to prove that f alpha into function of beta is equal to f of alpha minus beta. So let's first find out f of alpha minus beta. So f of alpha minus beta is nothing but we have to replace this alpha with alpha minus beta. So this is cos of, this is our RHS. So RHS is f of alpha minus beta. This is cos of alpha minus beta minus, it's minus sine of alpha minus beta is 0. So this is sine of alpha minus beta cos of alpha minus beta 0, 0, 0, and 1. Okay, let's keep it as a set of equation. Now let's multiply f alpha into f minus beta. So f alpha is given. So f alpha into function of minus beta is equal to f alpha is its cos alpha minus sin alpha 0 upon sin alpha cos alpha 0 and 0, 0, and 1. Okay, now minus beta is cos of minus beta minus sin minus beta 0 sin of minus beta cos of minus beta 0, 0, 0, and 1. Okay, now we have to multiply this, but before that, let's just simplify this. So our first matrix is cos alpha minus sin alpha 0, and this is sin alpha cos alpha 0, 0, 0, 1. Now this is cos of minus beta is cos beta. We know because we know that cos of minus x is cos x, and the sine of minus x is negative sine x. This is cos beta, and minus sine of minus beta is minus sine beta, minus minus is plus. So this is sine beta 0, and this is negative sine beta. This is cos beta is equal to 0, 0, 0, and okay, now let's multiply this. So this is called cos alpha into cos beta, and minus sine alpha into minus sine beta is plus sine alpha into sine beta. 0 into 0 is 0. So cos alpha into sine beta, this is cos alpha into sine beta, and minus sine alpha into cos beta. And 0 into 0 is 0. So cos alpha into 0 is 0. Sine minus sine alpha into 0 is 0. 0 into 1 is 0. So this is 0. Okay, next one, next row, minus sine alpha into, this is minus sine alpha into cos beta, and minus cos alpha into sine beta. So sine alpha into cos beta, cos alpha into minus sine beta, 0 into 0 is 0. So sine alpha, next one is sine alpha into sine beta plus cos alpha into cos beta, and then 0. So this is also 0. Okay, now 0 into cos alpha is 0, 0 into sine alpha is 0, 1 into 0 is 0, so this is 0. and 0 into sine beta, 0 into cos beta. 1 into 0 is 0, and 1 into 0 is 0, 1. 0 into 0 is 0, 0 into 0, 0, 1 into 1 is 1. Okay. Okay, now this is of the form cos A cos B plus sin A sin B, which is equal to cos of A minus B. And for this, we can take negative common. So if negative is common, then this term is positive. So this is sine alpha cos beta minus cos alpha sine beta into 0. Now this is sine A cos B minus cos A sine B, which is sine of A minus B. Sine A sine B plus cos A cos B, which is cos of A minus B. This is 0, 0, 0, and 1. Okay, so finally this is cos of alpha minus beta, and this is minus sine A cos B, so this is negative of A sine of A minus B 0. This is sine of A minus B cos of A minus B 0, 0, 0, and so this is F alpha into F negative beta. And if we compare this with f of alpha minus beta, so this is f of alpha minus beta, which is cos alpha minus beta minus sine alpha minus beta 0, sine of alpha minus beta cos of alpha minus beta. So from 1 and 2 you can write, so from 1 and 2 you can say f of A into f of negative beta is equal to f of alpha minus beta, and hence it is. And this solves our question number 32 in both the parts. And let's move on to question number 33. Okay, we are on to question number 33, where we have to find the equation of the diagonals of the parallelogram PQRS, whose vertices are given. So for question number 33, part A, let's say this is a parallelogram PQRS with given coordinates, and P is 4 root minus 6, Q is 5 minus 3 1, and it's 12 4 5, and it's 11 9 8 minus 2. Okay, so we have to find the equation of the diagonals, and equation of the diagonals, this is passing through 2 points. So equation of Vs, which is passing through 2 points, is given by x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So let's put in the values of x1, y1, z1, and x2, y2, z2. So this is now x minus x1 minus 4, and so 12 minus 4 is 8, y minus y1 minus 2, 4 minus 2 is 2, z minus z1, which is plus 6. So this is z plus 6, and 5 minus or minus 6 is 11. This is the equation of the diagonal PS. Similarly, equation of the diagonal QR as it's passing through 2 points is, this is x minus x1 is 5. So x minus 5 upon 11 minus 5 is 6. Y plus 3 upon 9 minus or minus 3 is plus 2, and z minus 1 upon minus 2 minus 1 is minus 3. Okay, let's say, so these are the equation of the diagonals. And let's say this is equal to some constant k and this is equal to some constant t. And for some values of k and t, let's say, so let's get the general points of for diagonal ps. And this x is equal to, if we equate this with the k, so this is equal to 8k plus 4 and y is equal to 2k. So this is for diagonal p, the general points. These are the general points that lie on diagonal ps for some value of k. So y is equal to 2k plus 2 and z is equal to k. It's z is equal to 11k minus 6. Similarly, the general points for diagonal QR is equal to x is equal to 6t plus 5 and y is equal to 12t minus 3 and z is equal to minus 3t plus 1. For some values of k, let's say these are the point of intersections of these two diagonals, and point of intersection of diagonal means that x and y coordinates are same, so let's equate them. So 8k plus 4 is equal to 6t plus 5, and let's equate the next one. 2k plus 2 is equal to 12t minus 3. So this becomes 8k minus 6t is equal to 1, and 2k minus 12t is equal to minus 5. So this is equation 1 and 2, and solving 1 and 2, let's multiply 1 with 2, which gives 16k minus 12t is equal to 2, and 2k minus 12t is equal to negative 5. This is negative plus plus. So this gets cancelled. 16 minus 2 is 14k, which is equal to 7, and k is equal to half. Similarly, we can get the value of t. So from this, we can get the value of t. So 2 into half minus 20 is equal to negative 5. This gets cancelled. 1 minus 20 is equal to negative 5 minus 20 is equal to negative 5. Negative 1. So 20 is equal to negative 6. And t is equal to half. So t and k are both the values are half. So now let's find out the point of intersection of diagonals by replacing the values of k and t. So point of intersection of diagonals, we can take any of these points. So let's take these points. So if we replace the value of t, so x is equal to 6 into half is 3 plus 5 is 8. Y is equal to 12 into 3, 6 minus 3 is 3, and z is equal to minus 3 into half is minus 3 by 2 plus half is negative half. So point of intersection of diagonals is 8, 3, and negative half. Okay, and let's move on to the next statement. So using these equations, find the point of intersection of diagonals. So we are done with the part A. Let's move on to part B. Part B says that a line passes through point. So a line L, it passes through the point minus 1, 3, minus 2, and is perpendicular to both the lines. So there is a line L that is perpendicular to two lines. Okay, this is perpendicular to two lines, and this line L is passing through minus 1, 3, and minus 2. Okay, so this is x by 1 is equal to y by 2 is equal to z by 3. And this is x plus 2 by minus 3 is equal to y minus 1 by 2 is equal to z plus 1 by 5. Now, equation of a line passing through a point, we know that equation of a line passing the given point is given by the equation x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. The equation of the line is x minus x1 is minus 1, so this is plus a, and y minus y1 minus b by b, and z minus z1 plus 2 by c. So let's say this is the equation of the line, and now line L is perpendicular to, let's say this is line 1 and 2. So line 1 is x by 1 is equal to y by 2 is equal to z by 3. So that means the sum of the product of the dash and cosines of L, and this will be 0. So this is a into 1 plus b into 2 plus 3 into c is equal to 0. So a plus 2b plus 3c is equal to 0. Similarly, L is perpendicular to the next line of this face x plus 2 by negative 3 is equal to equation of the line is y minus z by 2 and z plus 1 by 5. So sum of the product of the direction ratios of these will be equal to 0. So this is minus 3b plus 2b plus 5c is equal to 0. And let's try to solve these equations by cross multiplication method. So let's try to solve this equation by cross multiplication method. These equations have the variables a, b, and c. So this is a, b, and c, and hide the a terms, which gives me 10 minus 6 is equal to b. Hide the b terms, which is minus 9 minus 5 is equal to c. Hide the c terms, which is 2 plus 6. 2 plus 6. Let's say this is equal to some constant k. So a is equal to 4k, b is equal to negative 14k, and c is equal to 8k. So these are the direction ratios, which are 4k minus 14k and 8k. And we know the direction ratios are the multiples of some constant. So let's take out the constant k and 2, which will give us 2, negative 7, and 4. So these are the direction ratios of the line. So now it's been asked in the question to find the vector equation of a line. So vector equation of the line is r vector is equal to a vector plus lambda into b vector, where a is the position vector of the point through which this line is passing. So minus I plus 3j minus 2, minus I plus 3j minus 2k cap plus lambda into b. B vector is the line to which the given line N is parallel, and it has the direction ratios 2, minus 4, and 7. So this is 2I cap minus 7j cap plus 4k cap. So this is what was asked. And now we have to find the distance of this line from the origin. So let's say this is the space and this is the line. This is our line L. This is the origin with coordinate 0, 0, 0. And this is the line L. We have the vector equation of the line L. And we have to find its distance, that is the perpendicular distance from the origin. Distance means the perpendicular distance from the origin we have to find. Okay, now, so this equation, this line is passing through the point minus 1, 3j minus 2k. So we have to find it's not necessarily that it's the perpendicular distance from the origin. We have to find its distance from the origin. So the distance from the origin would be the distance between any 2 points that we take on line L. So line L is passing through, it's passing through -1, 3, and 2, and its vector position is minus I cap plus 3j cap minus 2k cap minus 2k cap. And the vector position of the origin is 0i 0j plus 0k cap. Let's say this is a2 vector and this is a1 vector. Now the distance from the origin is given by a2 minus a1 vectors cross with b vectors magnitude upon the magnitude of b. Now a2 minus a1 is I cap minus 3j cap plus 2k cap into the b vector is crossed. The b vector is 2i minus 7j plus 4k caps magnitude with the magnitude of b. So magnitude of b is 2 square 4 plus 49 plus 4 square 16. Let's find out the cross product. So the cross product of I cap minus 3j with 2 I cap minus 7j cap plus 4k cap. So this is equal to I cap, j cap, k cap, and it is 1 minus 3, 2, 2 minus 7, and 4. Okay, so this is 1 and it's minus 12 minus 12 and plus 14 minus 12 and plus 14 minus j cap, which is 4 minus 4 plus k cap minus 7 plus 6, which gives us 2 I cap. This is 0 and plus k cap. So we have to find its magnitude. So the magnitude of this is under root 4 plus 1, which is equal to under root 5. Now, so this is under root 5 and this is under root 4 plus 49 is 53 plus 16 is 69. So this is under root 5 by 69 units. So this is the perpendicular distance, and we have almost solved whatever was asked in the question number 33. We have obtained its distance from the origins. So question number 33 is done. Let's move on to question number 34. For question number 34, using the integration, we have to find the area of the region bounded by the line y is equal to root 3x and y is equal to under root 4 minus x squared. So bounded by the line and the curve, and y-axis in first quadrant, so that means we have to stick to the first quadrant. Let's get our plane first. Okay, this is x and y-axis. Okay, the first is the equation of the line. So y is equal to root 3x. So this is of the form y is equal to mx. So that means this line is passing through the origin. And the next equation is y is equal to under root 4 minus x squared, and square on both sides gives us y squared is equal to 4 minus x squared. And this is x squared plus y squared is equal to 4. Now this is the equation of a circle. And if we compare this with the standard equation of the circle, which is x minus h the whole square plus y minus y the k the whole square is equal to r squared. So the radius is 2 and the center is the origin. So center is the origin and radius is 2. So let's say, so this, we have to just stick to the first quadrant. So I will just draw the part of the circle in the first quadrant. So this is the circle, Okay, now this line is passing through origin. So this line passes through origin. And now we have to find the point of intersection of the line and the circle. So equation of the line is y is equal to root 3x, and equation of the circle is this is y is equal to, so y is equal to under root 4 minus x squared. So the area bounded by the curve, the line in the y-axis is this region. And solving this, let's try to solve this. This is equation 1 and this is equation 2. So solving 1 and 2, so y is equal to root of 4 minus x squared and y is equal to root 3x. So let's put the value of y, which is root 3x is equal to 4 minus x squared, and squaring on both sides will cancel out the root. This is x squared, so this is 3x squared is equal to 4 minus x squared, which is 4x squared is equal to 4, and x squared is equal to 1, which gives x is equal to plus minus 1. But we have to stick in the first quadrant, so we will consider the value of x as positive 1 and y is now root 3. So the point of intersection of this is 1 comma root 3. So let's say this is the area OAB and C. So we are first going to get the area under the circle in the first quadrant and subtract it from the area in this section. So we will subtract the whole area from this section. We will get the area OABO. So required area is area OABO, and this is, let's first try to get the area OACO. So this is area O, this is OACO, the whole area OACO minus area OBCO minus area OBCO. So let's get the area OACO, which has, so it goes from the limits 0 to 2. So it goes from the limits 0 to 2. Okay, this is, let's me actually get or try to, so this is 1. If I draw a line from here, okay, if I draw a line from here, so this is now 1 because the coordinates of this point are 1 comma root 3, so this is 1, and I'm going to get this the whole area. So let's say this is C, OABCO. So this is OA. I'm going to get the area OABCO and subtract it from it subtract the area OBC. Area OBC. So now both of these have the same limits 0 to 1. So this is 1 because the coordinates is 1 comma root 3. So this is 1 and this is C. Alright, so this has the limits 0 to 1 and OABCO is under the curve this. So this is y into dx minus this is also has a limit 0 to 1, but this is under the curve y is equal to root 3x, so y into dx. Now 0 to 1 y. For this y is the circle, which is under root 4 minus x squared into dx, minus for this y is the curve, that is the line root 3x, that's root 3x into dx. Okay, so this is of the form under root 3 squared minus x squared, which is x by 2 under root a square minus x square plus 2 sine inverse. This is 2 sine inverse x by, so x by 2 under root a minus x square plus 2 sine inverse x by 2, and has to be integrated for the limit 0 to 1. Root 3 is constant and into x square by 2 for the limit 0 to 1. Okay, now let's put in the upper limit. So this is 1 by 2, that is 4 minus 1 is root 3 by 2 plus 2 sine inverse 1 by 2, and after that it's 0. So minus 0 minus this is root 3 into 1 by 2 and minus 0. So which gives us root 3 by 2 plus 2 into sine inverse half. Half is off by 6 sine 30 minus 0 and minus root 3 by 2. So this gets cancelled. This is 3 and it's pi by 3 square units is the area. Okay, so this solves our question number 34. Let's move on to question number 35. For question number 35, it's given that the function is defined from minus 4 to 4 to 0 to 4 for the closed intervals. That means the domain is minus 4 to 4 and the codomain is 0 to 4. And it's given that the function is under root of 16 minus x square. We have to show that the function is onto function but not a one-one function. So function is an onto function when range is equal to codomain. So we say that the function is an onto function. Okay, now here it's given that f of x is equal to root of 16 minus x squared. F of x means the output y, root of 16 minus x squared, and y square is equal to 16 minus x squared. So this gives us x squared. So x squared is equal to 16 minus y squared, which gives x is equal to under root 16 minus y squared, that's plus minus. Now for the y, it's given that it's 0 to 4. So for each value of, so this function is undefined when y is greater than 4. But it's given that y has the maximum value 4. So for each value of y that belongs to 0 to 4, there exists uh, x that belongs to minus 4 to 4. So that means here the range is equal to codomain. Therefore, function is an onto function. Okay, now we have to prove that it's not a one-one function. So it's not a one-one function because the value for f of 1, the value is 16 minus 1 square, which is root 15. And we have got the same value for negative 1 and f and minus 1. So 1 and minus 1, both these belongs to the domain minus 4 and 4. So minus 4 and 4. And this is 16 minus of minus 1 square, which is again 15. So we have this in the domain, we have 1 and negative 1, and for both of them, it's root 15. So this is a many one function, and hence it is not one function. Okay, now it's also asked to find all the possible values of a for which f of a is equal to root 7. So it's given that f of x is equal to under root 16 minus x squared. So f of a would give us the value 16 minus a square, and now the f of a is root 7, so this is the root 7. So root 7 is equal to under root 16 minus the root 7 the whole square, which gives me the root 7 is equal to 16 minus 9. 16 minus 7 is 9. Yeah. Okay, we have to find the value of a. So this is 16 minus a square. We are not going with the value of a here. So this is 16 minus a square, and square on both sides gives us 7 is equal to 16 minus a square, which gives us a square is equal to 16 minus 7 is 9. A is equal to plus minus. So these are the possible values of a. And this also question number 35. Let's move on to the next section. We are going to cover up section E, and section E comprises of three source-based or case-based passages based integrated units of assessment of 4 marks each. So this says that the question number 36 says that the engine displacement is the measure of the cylinder volume swept by all the pistons of a piston engine. So these are the pistons in the engine, and they move in and out in a hole that is called a cylinder bore, which are in the form of circular cylinder open at top, and it is made from a metal sheet of area 75 pi centimeter square. And once you have read the information and understood, you have to answer the following questions. First one says, if the radius of the cylinder is r and height is h, then write the volume of cylinder in terms of radius r. So in terms of radius r, we know that the volume of the cylinder is pi r square h, so it should be all in terms of r. We have to get rid of h, and for that we should have some equation. Let's try to use the area here. So it's given that area of cylinder bore, which is open at the top, is 75 pi centimeter square. So which is open at the top means it's the base area plus curved surface area, which is equal to 75 pi. So this gives us h is equal to 75 pi minus pi r square upon 2 pi r. This is now equal to h is equal to 75 pi upon 2 pi r minus pi r square by 2 pi r. So pi and pi gets cancelled, and so height is equal to 75 by 2 minus this is r by 2. This is the height, and let's try to get the volume in terms of radius r. So I can also write it as, so this is actually 2r minus 2. So 2r is the LCM. This is 75 minus r square is the height. Now, the volume cylinder in terms of radius r, volume of cylinder in terms of radius r, we know that it's pi r square h. Let's put in the value of h, which is 75 minus r square by 2r, which gives us pi. So this gets cancelled. This is pi by 2, and it's 75r minus r cube. Pi by 2, 75r minus r cube is the volume of the cylinder in terms of r. Let's move further, and we have to find dv by dr. So next is to differentiate v with respect to r. So dv by dr if pi by 2 is constant. Differentiation of 75r is 75 and r cube is 3r squared. Okay. Now find the radius of cylinder when its volume is maximum. So for maximum volume, dV by dr should be 0. For maximum volume, dV by dr should be equal to 0. So that means pi by 2 into 75 minus Vr square is equal to 0, which gives 75 minus 3r square is equal to 0. So minus 3r square is equal to minus 75. R squared is equal to 25 and R is equal to 5. Let's check whether the volume is maximum or not. And when R is equal to 5, so let's find out the second order derivative. Second order derivative is this is constant, and minus 6R. So second order derivative when R is equal to 5 is minus 6 into 5, which is equal to minus 30, which is less than 0. Therefore, volume is maximum when R is equal to 5. Okay, so the volume is maximum when R is equal to 5. For maximum volume is height greater than radius or not. So volume is maximum when radius is R. So let's find out when volume is maximum R is equal to 5, and let's find out H as well. So H is 75 minus R square, which is 5 square upon 2 into 5. So height is equal to 75 minus 25 upon 10. So this gives is 75 minus R square. 75 minus 25 upon 2 into 5 is 10. So this is the height. Height is equal to 75 minus R square upon 2R, so which gives the 75 minus 25 is 50 upon 10, which is equal to 5. So that means when volume is maximum, radius is equal to height is equal to 5. So that means H is greater than R is false when volume is maximum. So it's false. And let's move on to the next question. Okay, for question number 37, it's given that the recent study suggests that roughly 12% of the world population is left-handed. And it's further given that depending upon the parents, the chances of having a left-handed child are as follows. When father and mother are both left-handed, the chances of the left-hand child is 24%. When father is right-handed and mother is left. So uh, out of the parents, out of these two, if one of them is right-handed, the chances of the left-handed child is 22%. When the father is left-handed and mother is right-handed, chances is 17%. So these are the cases when out of these two, mother and father, only one of them is right or left-handed. So the then chances are these, and when both are right-handed, the chances of the left-handed child is 9%. And L denotes the event that child is left-handed. So it's given that the probability of A, B, C, and D. It's given. So probability of a left-handed child, the probability of a left-handed child when both father and mother are left-handed is both are these are the four cases. The probability of A is equal to probability of C is equal to probability of D is equal to 1 by 4. And L denotes the probability of the child is left-handed. We have to find that first one, it says we have to find the probability of left-handed child when C. C means when father is left-handed, mother is right-handed, so it's 17%. So it's 17 by 100. Okay, and for the next part, it says that the child should not be left-handed, but should not be left-handed when both father and mother are left-handed. It should not be left-handed. So this is 1 minus probability of left-handed child when both father and mother are left-handed. So when father and mother are left-hander, the chance of left-handed child is 2400. So this is 100 minus 4, which gives us 676 by 100. So you can reduce it. So this is 2 3s are 6, 8, and 50, and 25, and 19. So this is 90 by 25 can be the probability. Okay. And third one, it says we have to find the probability of the left-handed child is selected, and we have to make sure that it's from the parents when both father and mother are left-handed. So this is, for this we are going to use the Bayes theorem, which says it is the probability of A into probability of left-handed child from the first option. So probability of A into probability of L by A plus probability of B into probability of L by B plus probability of C into probability of L by C. We have three options here, sorry, the four options. So the fourth one is when both the father and mother are right-handed. So we chance of left-handed child is 9%. So this is, we have to select the left-handed child is selected, and we have to make sure that we have to find the probability when both father and mother are left-handed. So this is by using Bayes theorem. So so this is 1 2 3, and we have what, which is probability of B into probability of L by. Okay, let's put in the respective values. So A, B, C, and D are 1 by 4. So this is 1 by 4. Probability of L by A is 24 by 100. So this is 24 by 100. So 1 by 4 into 24 by 100 plus 1 by 4 probability of L by B from option B is 22 by 100 plus 1 by 4 into probability of L by C. So this is 17 by 100, 17 by 100, and 1 by 4 into probability of L by D, which is 9 by 100. So 9 by 100. And this is now 24 by 400 upon 24 by 400 plus 22 by 400 plus 17 by 400 plus 9 by 400, which gives us 24 by 400, and this is 400. 24 plus 22, so is 46. 46 plus 9 is 55, and 55 and 17 is 72 by, so this is 24 by 72, which gives us 1 by 3. So 1 by 3 is the probability of the left-handed child from both father and mother, and they are both left-handed. Okay, this solves our question number. Okay, we have to, next is the part B as well. We have to find the probability that a randomly selected child is left-handed given that exactly one of the parent is left-handed. So one of the parent is left-handed is option B and C. So for B, it's the randomly selected child is left-handed, and it's left-handed when exactly one of them means either from B or either from C. So the probability of these is 22 and 72%. So this is 22 upon 100 plus 17 upon 100, which gives us 39 by 100. So this is the probability of getting a left-handed child and exactly one of the parents is left-handed, which is the option B and C, where the mother is left-handed and the father is left-handed. So either one of them is left-handed. And this is also our question number 37. Let's move on to the last one. Okay, we are on to the final question of this set series. And this question says that the use of electric vehicles will curb air pollution in the long run. So we are getting a lot of electric vehicles nowadays. Their use is increasing day by day to minimize the air pollution, and the use of electric vehicles is increasing every year, and estimated vehicles in use at any time is given by the function V. So if we put where T is 1, 2, and 3, and T corresponds to the year 2001. So that means if you put 1 in this equation, that will give us the number of vehicles in that particular year. So if you put 1, that will give you the number of vehicles in 2001. If you put 2, that will give you the number of vehicles in 2002, and 3 for 2003. So this is the equation 1 by 5 t cube minus 5 by 2 t squared plus 25 t minus. So based on our information, answer the following questions. Can the above function be used to estimate number of vehicles in the year 2000? So for t is 1 for 2001, and for 2000 t should be 0. So let's try to put 0 here, and let's see if it gives us the number of vehicles. If it's the positive, so that means it's valid. If it's negative, it's not. So 1 by 5 into 0 cube minus 5 by 2 into 0 plus 25 into 0 minus 2. So these all terms are 0, which is negative 2. And vehicles cannot be negative. So number of vehicles cannot be negative. So in a particular time, the number of vehicles cannot be negative, so given function cannot be used to find number of vehicles in a town. Okay, now we have to prove that this is an increasing function. Increasing function means that its first order derivative should be greater than 0. So let's try to differentiate this. So our function is Vt is equal to 1 by 5 t cube minus 5 by 2 t square plus 0.5 t minus 2. So differentiating this with respect to t gives us this is 3 t square by 5 minus this is 5 t plus 25. And we have to show that this is greater than 0, and for that let's try to get this in the form of, let's take 5 LCM. So this is 3t square minus 25t, and 5 into 25 is 125. And if I take 3 common here, so this is 3 by 5, which gives me t square minus 25 by 3 t plus 125 by 3. And this can be written as 3 by 5. And if we use completing the square, let me just try to get it in the form a minus b the whole square. So this is minus 25 by 3 into half, which is minus 50 by 6. So t square minus 25 by t by 3 plus 125 by 3. Let me add. So we don't have to take the negative sign, just multiply the coefficient of t with half. It is 25 by 6. So 25, this should be 25 by 6. 25 by 6. So I'm going to add and subtract the square of 25 by 6. So this gives me 3 by 5, and this is now t square. So this, and this makes up t a minus b the whole square plus 125 by 3 minus this is 25 square is 625 upon 36. So if I try to solve this, this is 3 by 5 into t minus 25 by 6, the whole square. So LCM of 3 and 36 is 3. This is 12. 125 into 12 is 10, 5, 2 into 1, 2, 5. So 10, 5, this is 1500 minus 625. And this is 3 by 5 and t minus 25 by 6 the whole square plus 1500 minus 6 to 5 is 5, 7, and 8. So this is 875 by 3. Now, this is positive. 3 by 5 is obviously positive. Square is positive. T minus 25 by 6 the whole square is positive. So 875 by 3, 36. This is 36. It's also greater than 0. So that means this is greater than 0. So because the first order derivative is greater than 0, so that means this function is increasing function. And this was this set of the series. Okay, so we have proved that the VD is an increasing function by proving that the first order derivative is greater than 0. So do like, share, and subscribe. Thank you for watching.